Hey guys, LuckyThandel here. I'm back in Delhi and I found this cool challenge I wanted to show you. It's a pawn challenge, PWN, pawn challenge. चलो देखते हैं what do we have here. So I'll try to do ls over here. You can see the Docker file. We have some directories over here that we're trying to copy from, and you can see the challenge directory over here where the actual content exists. The run.sh is there, the file system file is there, the kernel image is there, and then we have this entry point that is hosting the binary. And then let's just try to see what do we have in the challenge directory. And we can see we have these three files. Run.sh is there. Let's just try to see what do we have in run.sh. Okay, so QEMU is there. That is basically for virtualization, and we are trying to call out this kernel image along with the file system file. Yeah, that's it. So before I run this run.sh file, I want to check out what is there in the file system. So I'll just create this directory and I'll try to extract the content from the file system. As you can see, we have win dev etc init and every file over here, and you can see the tree command over here and the output of tree command over here. So you can see these are all the binaries that I have, which is pointing to the busy box obviously. And then I have this target binary that I can see, right? I just need to check what do I have over here in the target binary and in the init file. So init file is a shell script. So basically, I guess that is to establish the shell for the user that we are going to enter as when I'm trying to run the QEMU command. And I can see the UID is 1000. So like I'll have to change the UID to 0 if I want to log in as root. So then I can check for the target. It is a executable file, and I think like this is the binary that I need to execute, that I need to exploit. Sorry. And so I can easily see what do I have in the target binary using the GDB command. I can do info function command to see the functions, and I can then disassemble each function over here. So I can see in the start we have some assembly in AT&T flavor that I really don't like, but yeah, there you go. And in the one function we have this assembly. Okay, so maybe hex3 is for reading as per this syscall, because it is calling a syscall function over there at offset 16. And then I just want to make sure I don't leave anything behind, so I just want to check these symbols and everything with the readelf command. Okay, so I can see there are some symbol tables are there. The one is there, prompt is there. Okay, so basically I don't see anything else. Like this is a small binary, and I'm supposed to exploit this small binary only. I think I should move on to the production part. I should check for the production for this binary, and I can see some two segments as well. Okay, so this is the hexadecimal of the binary, and so I'm just looking for some strings. So I can see some strings over here. Like I don't want to execute it before I analyze it, so I'm just trying to analyze that strings. And where to go, challenger, reflection is your only guide. That is there. So it was compiled from assembly. Nice. So I just want to run it now, and I want to check how did it work, and it is asking for the user input. So I think this is where I'm supposed to supply it so many characters so that it crashes. And yeah, there you go, segmentation fault. Then I can check for the dmesg command as well. That is going to show me the kernel logs, and there you go. The kernel also says the same, that the instruction pointer was overwritten with the 414141. I can check for the binaries productions. in order to figure out what kind of attack do I need to perform on this. And I can do that using the checksec tool that comes with the PWN library. And as you can see over here, the NX is enabled. It basically means that it like we won't be able to execute our shell code inside the stack, since that is not executable, and we need to perform some rope gadgets. So it basically means that we need to perform the rope chain gadget attack. So for that we need to install the roper, and the roper is going to show us all the rope gadgets that are there on this binary. And I can install the roper using the apt command, and once that is done, we will be able to see the rope gadgets. So as you can see, we have some gadgets, but it is not enough, and we don't see any syscall over here. So we won't be able to craft any cell code using this. So that's why we're going to need this thing called VDSO. We're going to need some other gadgets as well in order to craft a whole cell code that is going to get us the shell. For this concept, for this attack, we need this thing called VDSO, which is virtually a dynamic shared object that is implemented by the kernel. It is basically containing, it basically means that it is going to contain some syscalls on the user level. So it is going to be there in the proc directory. Kernel is going to allocate its own space to this VDSO file for a process. So we are going to extract that VDSO file from a process. I'll be changing this process ID from 1000 to 0 so that I can get the root access on the file system. And then I'll compress it back to the file system. I'll create a file system with whatever I've changed, and then I can run the run.sh script. And you can see that we are root user now, and we have target binary over here. I'm going to execute target binary as a background process so that it will remain there in the background. Like it is gonna be there, the process is gonna be remain there in the background, but right now I need to check for its resources that has been allocated by the kernel, and one of those resources is VDSO file that I need to extract from its memory. So as you can see that a virtual address F7FF something like that is allocated to this VDSO memory, to this VDSO file. So I can use this dd command in order to extract this VDSO file. I'll do input file, and output file is that, and then BS is going to be 1, and count is going to be whatever that comes in after evaluating it. So I mostly do that with Python because it is easy with Python to calculate hex and decimal and all those values. Then I'm going to skip the previous content that I'm not supposed to take inside that file that I'm going to create with OF. And there you go. So you can see that I've created this. I can just convert that into base 64, and then I can copy that base 64 to my actual machine, and I'll paste that in to some file in my own file system, and then I can decode this base 64 in order to get the actual content of the VDSO file. Then I can easily do the file command on this VDSO that is going to show me that it is a ELF binary. And if I do roper on this virtual dynamic shared object, it is going to show me a lot of these things. And I can also see the syscall gadget is there, so I can use that syscall gadget in order to call some syscall, maybe to read or write. So we'll be covering that up in the next video. Thank you so much, guys. Meet you in the next one.